Let's go ahead and compare the differences between compressed air and uncompressed air. The model in front of you is from fosweb.com called Gas in a Syringe and is a very useful tool to compare the similarities and the differences between those. So first, let's take a look at the way this is set up. We have a syringe with a plunger closed halfway, and then the tip of the syringe is blocked so that no air can escape, and generally speaking, so no air can get in either. So I'm going to pause this for just a second here, and I want you to notice that the number of gas molecules or particles is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 particles. And I want you to notice that when the plunger is moved, whether by decompressing, by opening up and providing a lot more space for the particles, there are still 9 particles being represented. And if I compress this, notice I'm using the word compressed, by smashing these particles into a smaller space, they are still 9 of them. We can see 1, 2, 3, 4, 5, 6, 7, 8, 9. This is indicating that the mass of the air is unchanged. The number of gas particles is remaining constant because we aren't changing the amount of particles that are in here. What we are doing is we're changing the space that gas is occupying, which another word for space would be volume. So when I pull this plunger all the way up, I've increased the volume of the air particles, and when I have pushed the plunger down, I have decreased the volume. And you can see there's less space between the particles, but the actual particles themselves are not being changed. When air is compressed, the particles themselves do not change volume. It is the space between the particles that changes. Notice the difference in the motion of the molecules. So that was the third question over here. When we open this completely open, all the way up, the plunger, giving it all that volume, you can see that the particles are slower moving, not as quick. And the more this plunger is pushed, the quicker those particles begin to move. So that is another difference. Air particles move much faster when they're being compressed, and they move slower when they're not being compressed. Okay? So I'm going to go ahead and let this go down like this. It's going to kind of find a nice little balance point in the middle. Now, there is a reason why that is happening, and I'll end with that reasoning. But first, I want to talk about the pressure gauges and to compare the inside air to the outside air just to see how pressure is increasing. Now, pressure is basically any time one of these particles makes contact to an object, it applies a force. A push, if you will. And that's true of any object in any reality that you talk about. If you caught a baseball and someone threw it at you hard, you would feel the pressure of that throw. Even if they threw it soft, you would feel the pressure of it landing in your glove. Well, these particles move just the same way that any other ball or any other object would move in a bigger scale, but these are just small and can't see them, so we sometimes forget that they're doing the same thing, and that is bumping into things and applying force. If I show the pressure gauges here, you can see that they're both equal, and that's comparing the outside air to the inside air. So I want to show you that as we increase the compression, or as we compress the air, the gauge on the right starts to increase, which means there is a relationship, a correlation, that the more air is compressed, the more the pressure increases. And this is basically because of what I said earlier about the baseball throw. If you throw a ball harder, it moves faster, and when it hits harder. That's true here as well. The faster the particles move, the harder they hit. The slower they move, the weaker they hit. So let me end with this concept right here. If we show the surrounding air, the reason why this syringe, this plunger portion, is not moving in or out is because both the outside air and the inside air are pushing with equal forces. And since it's equal, as one bumps on one side of the plunger and the other one bumps on the other, nothing moves. In order for this plunger to move, the force has to be greater on the outside or from the inside. And when this is pulled open, the pressure on the inside weakens and the air outside is still just as strong as it was. If you see the gauge on the left, it hasn't changed, but the one on the right has dropped. So when I let this go, the air particles on the outside are stronger than the inside and is able to push this plunger back closed. until there's a balance or an equilibrium reached. And the same is true if the plunger is closed all the way. Those particles on the inside are moving so fast that they are stronger now than the outside air. And when the plunger is let go, those air particles bounce and push and push and push, kind of looking for extra space to get back to a balance point. And if all this conversation about pressure is stressing you out, take a little time to decompress.